I'm Reese Grimsley, and I'm making this video to show people how they can use the EnviSense programming web page and API, which is made so that it's a little bit easier to program these EnviSense data loggers and the schedules they use that set their sampling behavior. So we have this repository that's hosting all of the code, and it has a lot of instructions for what the schedules are for, what the API and the web server do, and how to install them, but I'm mostly going to be focusing on how to actually use this web server. So I have one small window here at the bottom that's just showing a few messages that the server on the back end will be showing, but we can generally look past that and instead just focus on the web server and the web page that it provides us whenever we go to that website. So I'll load that up here in this other browser tab, which is going to reach into this same machine that's hosting the web server. So we see that it loads up, and we have a bunch of devices that it's populated from what devices we know about on the actual backend server, as well as a lot of fields that I'll explain here as we go through it. All of these do have tooltips to help users figure out what each of these different fields and forms actually do, but this video is designed to show you what the flow sort of looks like. So I'm actually going to start off down at the bottom so that we can create a new device. And creating a new device for an EnviSense basically means providing a dev UI. It's a unique identifier that LoRaWAN uses to identify devices whenever they try to join the network, and it gives it a way to provide some access keys so that it can authenticate without having to have those keys loaded directly on the device at all times. So I'm basically just going to make up a dev UI here. It's not too important exactly what this string is, so long as it's 16 characters hexadecimal, where hexadecimal is just where all the characters are 0 through 9 or A through F. And so we'll give it some random name. Let's just call it test device 1, 2, 3, 4, 5, 6. And I can create the device. This little SDI12 enable checkbox, the main thing that's doing is just telling our backend, whenever it creates a device, what the device's default schedules should look like. So I'm just going to go ahead and create it, and it should return pretty quickly. So we saw a little bit of information back here, and that's showing basically that the device got added to ChirpStack, which I'll show up in this window. So this is ChirpStack. It shows the devices that we have connected and known about within our LoRaWAN network. So we have different applications. Generally we use application ID 1 just for simplicity. So if I scroll down to the bottom, we'll see this new test device 1, 2, 3, 4, 5, 6, and it has that dev UI we asked for, and it pulled some information about this device profile and some of the application keys from a configuration file that would normally be set up during the installation process, and I'll leave that to the README to explain. So there's some information in here about application keys. Not all of these are necessary. The device has never shown up yet because I just created it, so it wouldn't have shown up as activated. But if there were an EnviSense that had this dev UI, we would see it show up here the first time that it joined into the network. So we added it to ChirpStack, and we also added it to our SQL database. So the SQL database is holding onto information about where devices are deployed, or rather some information about their deployment, like the distance between the stream bed and the sensor, assuming that you're using like an ultrasonic non-contact sensor. So that's the deployment. We can see that that was added in here. We just gave it some null value because we didn't know what to put in there. There's also a device field, and this is a little bit more obscure. This is about how it knows which schedule that it needs to be downloading. So somewhere down here, probably closer to the bottom, we have the device that we just added, and it thinks that it wants to use schedule A, which I'll describe more of what that means in the future. And it also gave it a set of default schedules. So I could go through here and show you, exactly what all of these look like for A, B, C, and D, but instead we could just use this API itself to do that. So the second feature is querying schedules, and the device that we added isn't here yet. So if we reload the page, it will show up whenever we look into ChirpStack. So this time we saw the device that we just added, and we want to look at whatever schedule A had. There are 4 schedules, and these can be completely different from each other. They can be swapped between on the devices by changing the pending schedule. I'll get to that in a little bit. First off, we can just query it, and that'll return back basically what was in these tables directly here, and it'll populate each of these fields. So this device selector and the hours selector will show exactly which of these to use. And we can change that really quickly in here. For schedule A, each of these schedules were identical. And if you read this a little bit, you can see that we're actually sampling what we call the kitchen sink, which is everything but the kitchen sink. We sample all of the sensors and put them into a LoRa frame. We're doing that every 900 seconds, every 15 minutes, and sort of near the end of the hour, we will try to download the schedule. And do that identically for each hour. And that's default schedule A, and that's what we put in whenever the device is created. The user is free to change those however they want with write. Schedule B is slightly different. Every hour is still the same, but we only read at the top of the hour, and we won't check that again. So this is sampling every hour instead of every 15 minutes. Schedule C is similar, except we schedule to sample every 6 hours. So hour 0, hour 6, and so on are the same, but hour 8, there will be nothing done during this hour. So we only sample every 6 hours and send that information. And this is mainly so that we can save battery life on the device. Schedule D is really just a repeat of Schedule A. It's reading every 15 minutes or so. So let's change that a little bit. Actually, let's go to a different device, the one that I have on my benchtop here, EnviSense 24002. We will query for that. Let's take Schedule A, for instance. So we just read that, it showed up. And now we want to go and write a schedule. So within these fields, we want to add a new schedule, so the next time we query for, let's say, Schedule D on that test device that we created, we'll switch it here, and we'll update all the hours for it. We'll select the device that we want to write to, test device 1, 2, 3, 4, 5, 6. We'll leave this exactly as it was, since it was copied from this device here, and we'll write that. It'll finish pretty quickly. So if we look back over here, and I reload the page within the SQL database, we see that it just added something new. And now it's kitchen sink, read SDI12 kitchen sink, and so on, and it exactly matches whatever we had written in here for that other device. And we could have been reading multiple devices all at the same time, or programming them all at the same time. So I could select a bunch here, and whenever that returns, it'll give us a little bit of an indication that something's new, generally by populating these fields. If we're to write something, we can write to multiple at a time. Put that into A. It'll also give us an indication that that finished successfully. Since there's nothing to update in these fields, it'll give a little pop-up. Okay, so we've created a new device, we've looked at the schedules that were put in it by default, we've written a couple of other schedules based on basically copying from a different device. And anyway, you could change all of these fields. These are the set of functions that an instruction for a schedule can include. It has a parameter, usually 0 is fine, but for something like, say, send LoRa frame now, this parameter is doing something like setting a random delay so that multiple sensors with the same schedule don't conflict with each other in the air. And the last feature that this implements is updating the pending schedule. And so I mentioned how there are 4 different schedules here. So EnviSense will implement 4 schedules that are stored locally on the device. And those can be updated independently however the user likes. They can have an arbitrary setup of these instructions and the seconds and the parameters. But to make it a little bit easier to switch between them, rather than downloading 24 of these schedules worth of information every time something changes, we can just tell it to switch to a different schedule ID, switch from Schedule A to Schedule B. And so that's what this pending schedule means. It means that whenever the device next checks in, which is done by this download schedule instruction, whenever it checks in, it will try to look for, well, whatever the pending schedule is. So if we looked into the device table, and then down at the one that we just created, so this is showing B right now, or excuse me, A. A is the one that we just created. This one right here. So let's say that we want it to use schedule C, and just really quickly, we'll show again that that is the sample every 6 hours. So we'll update that really quickly. And then if we show that here, we'll see that this was updated to C. So the next time this device, if it were connected, requested a new schedule with this download schedule instruction, it would look for this particular schedule. It would look for the newest version of this schedule C. So that covers most of the functionalities that are built within this web server. There are more functionalities built into the API that this implements, but I won't be showing all of those right now. Those are well documented. There's plenty of comments within the API code within the repository, but I'll leave that for the next person to cover. One thing to mention is that if something goes wrong, if things aren't working out, there are a couple of things to check. One of the first places to look for issues would be in the developer console within the browser. So I use Firefox. I've also tested in Chrome and it works, as far as I can tell, exactly the same. But usually you can look at the console, which just shows some logging or error messages by finding this web developer tools, and then looking at the console. So as we, let's say, change which hour we want to look at, we'll see some extra, information around here. It's trying to look for the schedule to display, the hour, the schedule ID, and it'll update the instruction fields. And so it's just giving some information as the web page is changing, and as it makes requests into the backend, some of that information will also be shown within those log files on the server itself. So hopefully this is a good introduction to how to use this EnviSense programming API in web server. Please let me know if you have any questions. You can contact me at reesg@cmu.edu, or consult any of the READMEs or APIs within this repository. Thank you.